2018, a crack YouTube unit was sent to social media prison by an algorithm for the crime they didn't commit. These producers promptly escaped from maximum security social media stockade to the internet underground. Today, still wanted by social media, they survive as producers of fortune. If you have a problem, if no one else can help, and if you can find them, maybe you can hire the Smash Team.
And thanks for tuning in, everybody, to the Daily Space Weather. We have gone live once again, hoping everything is working appropriately. Please keep us apprised of the situation. smAsho staff. We're looking at the sun here in 193 angstroms to see pretty low levels of activity. No sunspots. Diffuse coronal hole near the equator there, rotating into the Earth-facing region. Again, low levels of activity. Here's the 335 angstroms view. And we're looking at approximately 11 hours of solar activity here. And we did see some interesting X-ray activity near the South Pole on the GOES X-ray imager. And in this area, you see a little fleeting area of X-ray kick up right near the South Pole there. Kind of odd. And I'll just bring this back and let it play through. This is 48 hours, I believe. You see a little area of X-ray flux kick up. And we took a look at stereo A, no coronal mass ejections. Here's the helio viewer view. We're going to look at the magnetic fields and the 171 angstroms view. The most magnetically complex region is here under my pointer, not a sunspot. Here's the fade out. You can see the fields associated with that plage. It's quite small, and not a lot else to say about that. Let's look at some more data. Electron flux is in a nominal range. Relativistic electrons also in a nominal range. GOES magnetometers are looking fairly smooth here. We're solidly in the South Pole aspect of the current sheet, shown here on the Gong 2 data in red. This data 1 hour and 57 minutes old. Keep in mind it can change with no warning. Haha. And let's take a look at the solar wind data. Here's the last 24 hours. According to the Discover craft, phi angle 267 degrees, solar wind density 3.72 protons per cubic centimeter. Solar wind speed dropped down to 369 kilometers a second. Here's the ACE data looking similarly. Magnetosphere is looking weak. Here's the pressure in our daily geospace magnetosphere movies. We'll let that play through to archive 4 hours of data as we do most days. And that weak solar wind not inducing a lot of current. You're going to see a small kick up in the magnetotail here toward the end of the video. Otherwise, again, not a lot of induced current here. Here's the ground geospace magnetic perturbations. And we see the South Pole looking like it's creeping into the southern Indian Ocean, as we've been watching for months. And the main current is in the North Pole, the Canadian North Pole here, as opposed to the Siberian North Pole. By the way, if you like the music, check out soundclick.com/GoldenCat Productions. This one's called Hemis Here, as we look at both hemispheres. Yes, there is all kinds of science stuff osmotically drizzled into the music. Anyway, there's 4 hours of data, courtesy University of Michigan. Now let's look at the ionosphere, and we've been seeing continued anomalies in the South Pacific, southeast of Hawaii. Sudden charge ups and charge downs. And you can see charge up anomalies there, southeast of Hawaii. We've been seeing it for 2 weeks. And here's the latest image. That one from 11:15 UT. And you can see extreme charge disparities there as the ionosphere. You got this green area, which is 4 megahertz, right next to this 1 megahertz F1 layer area. And the KP index has been at 0 for the last 6 hours when we made the video, and it's now 6:22 a.m. We apologize for the lateness. Let's look at the cosmic ray stations. Here's Apatity and Barentsburg. Next we'll look at Athens. And we have left links to this network of cosmic ray stations site in the links below the video. If you're viewing live, you won't see the links. But if you're viewing on YouTube or BitChute perhaps, the links will be in the description. Here's the Athens neutron monitor. Nothing to write home about there. Let's look at Mexico City next. And there's the cosmic ray data from Mexico City. We did actually see a pretty significant spike. Second highest readings just before midnight last night. Moscow is next. And there's the Moscow neutron monitor. And lastly, let's look at Oulu and Antarctica, DOMC and DOMB. There's Oulu. And Oulu is actually showing the pretty sustained highest levels here that we've seen in the past 30 days. Here's DOMC Antarctica, fairly flat there. And here's DOMB Antarctica, not sending back any data for quite a bit. Again, links to this Cosmic Ray Stations site are going to be below the video. Let's talk about the human health effects of cosmic rays. Now, this is the main reason why it's a stupid idea to go to Mars, as it is a suicide mission. You're pretty much guaranteed death somewhere between when you're at Mars and when you're on your way back. So it's not something I would be volunteering for. And cosmic rays do have various effects on human health. So the human body operates on very sensitive electrical fields, and the secondary particle showers as well as the direct radiation contact associated with cosmic ray flux has all kinds of effects on human health. And so we're not only talking about when we see a solar storm, we're also talking about when we see very low levels of solar activity. So a KP of 0 is dangerous in a different way than KP 7, 8, or 9. But you're getting some similar effects there, and we've left links to this also. This is from the website infogalactic.com, and the whole entire article is about cosmic rays. So there are all kinds of central nervous system effects. Cosmic rays can cause cataracts. They can cause things like strokes and heart attacks for people that are prone to that sort of stuff. There are various different mitigation techniques, and we're considering the options of magnetic fields to mitigate, as well as different other kinds of shielding and spacecraft and so on. So read the article if you're not familiar with human health effects of cosmic rays. And let's move on to earthquakes. The largest of the past 24 would be this 6+ magnitude, listed as a 6.0 near Tonga. And there's a location of that quake. Everything's showing up green on the pager there. That 6 magnitude quake doesn't look like it really did too much. No apparent tsunamis associated with that. And let's just scroll up the list of the past 24 hours. That one came in at 13:04 yesterday, UT, which stands for Universal Time. And thanks, new viewers. Thanks, everybody who's recently subscribed. And we also saw a 5.7 aftershock there at Tonga. Here's a quake in California that's at a depth of negative 0.1. In other words, 100 meters up above sea level. It's only a 2.7 magnitude, so we're not going to dwell on it. A couple small quakes hitting Hawaii. Here's a nearly 100-kilometer quake at Japan. That's a 4.5 magnitude. Here's one of the northern Mariana Islands. That one's at a 4.6 magnitude and 159.9 kilometers depth. A small deep quake at Alaska. And here's one in western South America at a 4.4 magnitude and 178 kilometers. Deep quake at the Dominican Republic at a small magnitude. Another deep quake in southern Alaska. And let's move on to the pressure maps at windy.com, in theory. All right, and let's zoom out here and let this play into the forecast and get that crap off my screen. Thanks. There we go. Windy.com also has a great mobile app. It's free, available at windy.com. And let's advance the pressure cells here. We'll let that play for about 24 hours according to the windy.com GFS forecast. Powerful low in the northern Pacific there, very spread out. Dueling anticyclones over the North Atlantic. And high pressure above my head should make for clear skies. And there's where pressure cells will be in about 24 hours. Again, it's 6:28. Do you know where your pressure cells are? Volcano rundown is going to include Mount Aso still producing an 8,000-foot ash plume. Sakurajima back on the list. Flight level 9,000. Sanjiangapi, flight level 8,000 as it explodes. Dakono exploding as well, 6,000 flight level there. Fuego exploding, flight level 15,000. Sangay, apparently there's a report, volcanic ash emissions seen with Summit webcam. So Sangay kicking back up perhaps. Revenador exploding, 16,000-foot ash plume there. Sabancaya intermittent emissions. And Nevados de Chilean exploding, producing a 12,000-foot ash plume. Please don't pole vault Nevados de Chilean. There's where things are in the solar system, and there's where they'll be in a week. If you'd like to make yourself a sky map, check out in-the-sky.org. You can even animate it. I see Cygnus and Mars and Mercury have just risen. Look for changes coming soon at smashomash.org, smashomash.com. The forum is going to be ready soon. So check this out. It's got links to some of our social media here, as well as the ability to fund our channel. And thanks to our patrons. Also look for us on other social media, everything from Gab to Twitter to Facebook to BitChute. Making sure that our videos are archived there, as our YouTube channel could be deleted at any time for no reason and with no explanation. By the way, we've flagged YouTube once again for citing some content that has been identified by the YouTube community as inappropriate or offensive to some audiences. Now, this was not an offensive video in any way, since Google is a criminal organization, we like to cite that regularly on the internet, since Google can't break the internet, but the internet can break Google. Let's talk about terrorists, eco-fascists, wearing anti-fascist shirts. That's right. Apparently, the Thunbergs, I assume these are Greta's parents here, who are clearly guilty of child abuse, filling this poor child's mind with lies, making her believe that she can see carbon dioxide, and then parading her around wearing Antifa shirts. An organization recognized as a terrorist group. At least I think the Seattle one is. I know a few Antifa chapters have been officially recognized as terrorist organizations. Perhaps that's giving them too much credit. Maybe they're just dummies. Anyway, Greta's very mad because following her appearance in Spain, apparently she hasn't been seeing any sort of a decrease in carbon emissions, something that people who don't understand atmospheric physics think has to do with the Earth's climate. People want everything to continue like now. They are afraid of change, she told reporters, without mentioning the world's #1 polluter by volume, China. And change is what we, the young people, are bringing, and that is why they want to silence us, even though mainstream news has her all over the place. And that is just a proof that we are having an impact, that our voices are being heard, and that they try so desperately to silence us. Nobody's trying to silence you, Greta. We would just prefer if you take a freaking physics class and get a clue how the atmosphere works. Perhaps understanding the fact that Earth's heat latency lies in the oceans, which you're standing on top of right now, and not in the atmosphere. The atmosphere only contains 1% or less of the Earth's heat latency. And the Earth's climate takes a couple of years to even catch up to solar activity, which is why it could be even colder next year. Please leave a comment if you've had a late spring or an early winter the last 3 years where you're located, like me. Lightningmaps.org is showing some pretty inactive lightning. Not a lot happening, according to lightningmaps.org. In fact, the only lightning happening there is just looks like near New Zealand. It's a lightning lull, folks. And welcome to the value-added services section. Here's a U.S. Doppler radar animation. Still seeing some snow around Lake Michigan and most of the state of New York as heavy rains begin to fall in Washington, Oregon, and California. And some snow continues to fall on the Tahoe region. Shout out to those folks living in the Tahoe area. Next, we'll look at the water vapor map. And we see quite a convergence zone here over Colorado, as we often do. Pardon my zoom. We're going to zoom in on that zone actually right in the middle of Colorado there, as we see some interesting cloud patterns likely to be developing. Speaking of developing, go out and take a photograph if you see some lenticular clouds today, as this is the sort of environment where they'll form. Come on, you can do it. I know you can do it. There we go. Look at those insane convergence lines happening there. You can see how the water vapor is forming into straight lines. And it's not a coincidence, folks. The universe has very few coincidences, if any. And let's head to nullschool.net. Look at the jet streams. Here's the eastern world. Doubled up jet streams and some backwards portions there. If you see the jet stream moving east to west, that's a backward jet stream, as is happening here over the northern Middle East. Here's the western world, I think. There we go. Make sure I have Alaska showing up there. And more extreme meridional jet stream flow. We're expecting to see incredibly cold temperatures in northwestern Africa once again. Please consider supporting the channel on Patreon, patreon.com/smashamash. Thanks associate producers on Patreon, the real funding of the channel, as YouTube comes up with excuse after excuse to pay us precisely $0 for our content. And if you enjoy the content on YouTube, please press like and subscribe. Apparently we have a premiere happening. I must need refreshing. It's refreshing to refresh. And I don't know, I guess you just press the button more than once. Check out yesterday's thumbnail featuring the Parker Solar Probe. And we're going to get back to the Parker Solar Probe in a minute here. And thanks to our latest value chain partner, Twitch Gaming. By the way, you can also fund us on PayPal. And thanks again, Smash Team, for viewing, whether it's viewed on the Smash stream, on BitChute, on Twitch, or wherever it happens to be. Now, I like fast things. And let's talk about really fast things. The fastest thing ever built by mankind, as far as we know, it's the Parker Solar Probe. Getting some very detailed images of the solar corona. And that's not from the Parker Solar Probe. I just wanted the image there. And we're going to talk for a minute about the ESIS system. And this is a very exciting scenario here, as this instrument has already been allegedly picking up some heavy elements that were not expected to be found in the solar atmosphere. So, with the onset of the Sapphire project, producing heavy elements in its atmosphere, I believe we have a new cosmic tool in the cosmic toolbox. In other words, apparently stars are able to make heavy elements in their atmospheres. And this is kind of important, as this is yet another thing which is killing the Big Bang and gravitational accretion astrophysics, as it looks less and less likely that gravity is the primary force governing the structures of the universe. In other words, cosmology does not appear to be entirely ruled by gravity. There are some other forces at play. So let's talk about some data to be released from the Parker Solar Probe. Now you're going to see no less than 4 different sites linked here, and we've linked to all of these pages so that you can go check out the data yourself. First of all, let's talk about the ESIS. There is public data available from the ESIS, and if I could freaking scroll up, I would be so happy. But I guess it's not going to work. So, yeah, I just completely locked out of the page. Let's try again. There we go. There's the top of the page. Isn't it beautiful? The ESIS page. And I swear, I don't know what the hell is up with this. But we've left links to it anyway. And you have to ask permission to get the level 2 data, but you can get public data. And I'm getting off this page before I decide to yank the plug out of the wall from my computer like I'm starting a lawnmower. So anyway, here's more information about the ESIS, which is the Integrated Science Investigation of the Sun. And one of the more interesting instruments. And there's a whole suite of instruments on here. We can't go through all of it in just one video, and this is going to be a common subject on this channel for weeks to come. There's also the SWIAP, which is another instrument on the Parker Solar Probe. And this is going to have more of the regular sort of data that we're used to looking at, as this one is measuring protons and alpha particles, otherwise known as helium nuclei, and electrons when they show up. It's able to measure proton speeds from 138 to 1,072 kilometers per second. So there's some of the facts. It must tolerate temperatures to 3,000 degrees. And molybdenum. Yes, molybdenum. There's molybdenum involved, folks. And anyway, have a read about that if you're not familiar with the SWIAP instrument. And we'll be looking at data from that. Here's a page about the data, complete with release notes and so on. Here's one of the links from that page. Actually, this isn't one of the links from that page. This is about the Whisper, which is the only imaging instrument on the Parker Solar Probe. It's got an inner and an outer camera. And here's some data that we pulled from this. This is available on that page that we were just on. So this page here, it's this is a Navy.mil page actually. But if you scroll down, there will be some links to various different files there. And we just pulled up one of them just to give you an idea. And here's a great image by the Parker Solar Probe from earlier this year in April. The images on the left are the inner camera. Images on the right are the outer camera, and they've been so kind as to splice them together for us. And those are some very, very close-up, detailed images of the corona. And lots of interesting data to be crunched, and there's going to be a lot of data to be crunched. Now this animation, this is from the SciTech Daily article, and this is showing the way the magnetic fields snap back and forth as the solar wind comes out. The fields will suddenly reverse and then revert back to their original orientation as the primarily protons, primarily hydrogen nuclei, come blasting out of the chromosphere. So one of the unexpected things that were found, and we're going to keep linking the SciTech Daily article for those of you who have not read that yet. It's a pretty in-depth article. And let's get back to cosmology. We're talking about Reuters Pictures of the Year, space. Now, I'm not happy how they started this because they started it with an artist impression. And I'm not a fan of artist impressions when it comes to space stuff. We try to look at real images here, not drawings. So no matter how sophisticated your computer is, your drawings aren't real data. So in any case, here's another artist impression of a galaxy known as NGC 4993. Here's the Hubble image of that galaxy. And I don't know why they made it so fluffy, but we've left links to that page here. This is the Hubble page. And let's go through some more images here. Here's another artist rendition of a black hole. And here's the Crab Nebula, the most powerful X-ray source in the sky. Here's an M-class solar flare. Here's the Calabash Nebula. This one warrants further study. This is believed to be the death of a sun-like star. Here's some more artist renditions of black holes. And here's a solar eclipse that happened earlier this year. Space station images. Here's a Soyuz spacecraft. Artist renditions. Here's a composite image showing, I believe, radio, X-ray, and visible light on Able 3411 and 3412, which is one of the most massive galactic clusters known, I believe. Here's NGC 2623, otherwise known as ARP 243. That one could be a good one for further study. And without getting into the entire thing here, surface of Mars, NGC 5949, Westerland 1, a superstar cluster, Saturn's moon Dione, a Soyuz MO6 craft taking off, an image of Saturn with the Cassini mission, with the Cassini probe spliced on top of it. Anyway, check that out. Reuters Pictures from Space. We'll go through all 35 of them. It's a great image of the Great Red Spot, an anticyclone high pressure zone. Don't be convinced it's a storm, folks. It's a high pressure zone, an anticyclone. And last but not least, the sun obscured by the moon during a solar eclipse as seen from Alaska on an airplane. Nice donut shape. Again, links to this Reuters article as well as to this. Let's talk about a very strange object. Let's go into geology. How about the realm of geology, folks? Are you familiar with the Richat structure? Well, here's an image of it. Now, this is widely believed by geologists to be the result of, can I get a guess? Can I get a guess? Erosion. That's right. People believe that this formation formed as a result of erosion. Let's take a look at where it is on the map. It's in Mauritania here in the Western Sahara. And let me just zoom in. Now this thing is nearly 30 kilometers in diameter. The Richat structure. It is associated with this large, dark portion, which looks like a bunch of igneous rocks. Yet, how could they have formed through volcanism? Now, some people thought this was an impactor, and yeah, the Richat structure. Talk about electrical scarring on the planet. Yeah, that's pretty tough to argue. Just the idea that a structure like that could be formed through simple erosion is just hilarious. Here's another image, as well as an article of the Richat structure. Please have a read about that. Now let's get back to cosmology real quick, talking about the Galaxy Zoo. Now, Zooniverse.org is the largest citizen science project in the world. Galaxy Zoo needs humans to classify galaxies, so let's just do one to show you how it's done. That galaxy's smooth. You only want to do the one in the middle. No companions. It's in between being round and cigar-shaped, as we're looking at it from a slight angle here. I don't see any sort of a disturbance or merge. And there's really not a lot going on there. There's a barely visible bulge in the middle, but we didn't even really cite that as a feature. We're just going to say nothing unusual there and move on. Will you be the citizen scientist to classify this elliptical galaxy? Again, computers can't do it. We need people. And set yourself up a login. You could even get published in some sort of an astronomy paper, if that matters to you. Now let's talk about more stuff flying in the face of mainstream cosmology. Apparently, there's a planet which is larger than its host star. Now, white dwarfs, the death of stars, and so on is not something that's ever been observed. In fact, we even found the star in the center of supernova 1987, which is no surprise to some people and a complete surprise to, I'll say, mainstream cosmology. How it's possible for a planet to be larger than its star is anybody's guess. This one appears to be 4 times the size of the star. And the star is, I don't know, it's still hot enough to be burning off large quantities of this planet, giving it a comet-like tail. And this is an artist rendition, by the way. And if you want to read more about it, look up WDJ0914 plus 1914. And that's also not real data. Such a system has never been seen before, and it was immediately clear to me that it was a unique star. Yeah, they're all unique stars, folks. And so anyway, links to this article from Universe Today listed below the video. Please leave a comment if you have ideas as to how a planet can be 4 times larger than the star it's orbiting. What are the most energetic explosions in the universe? Well, they're gamma ray bursters. And the truth is, folks, we don't know how they happen. Mainstream astronomy believes this is caused by stars collapsing into black holes, and black holes are not something I believe in, as once again they've never been observed. It's pretty hard to observe the spectra of an object that absorbs all the light, right? Well, turns out synchrotron radiation appears to be causing the gamma ray bursts. This is caused when electrons are heated up or sped up to relativistic speeds, and then when they slow down, they lose an energy state, they emit a photon. And let's just say there has to be solid magnetic fields in order for these electrons to be concentrated in these manners. Magnetic fields run the universe. And it just becomes more and more obvious on a daily basis. So have a read on this SciTech Daily article about where gamma ray bursters really come from. Thanks again for tuning in, viewers. And again, please consider supporting the channel on Patreon, the real source of funding for our channel, and we need a lot more in order to reach our goals. And also thanks to those who have been viewing live on Twitch. Cheers. And welcome to the Neo-Renaissance, by the way, as cosmology and astrophysics are getting rewritten before your very eyes, and thank goodness, because the implications on things like human technology will be, let's just say, vast. And let's go to a bonus feature, Smash Team. We're going to look at one more image of the sun here. And I guess we'll do it in 131 angstroms. Now, it might take a minute to load, so have patience. And please take the time to leave a comment. Please share our videos on your social media. Please help us to get unshadow banned. Now, we are ungoogleable on purpose. Are you ungoogleable? Now, of course, we're becoming less ungoogleable as time goes on. But in any case, here's the local yellow dwarf. It's about 11 hours worth in 131 angstroms. Here's the southern portion, complete with date stamps. We are out of here, folks. Thanks again for tuning in, everybody. Look for more content likely coming out this afternoon. Remember to stare at the sun and not to drink, and if you do, don't drive. Certainly don't drive. At all costs, don't drive. And since it'll never be now again, may that solar wind be at your back, and that atherosclerosis absent from your veins.